Hello everyone, how are you? I hope you must be doing fine. So in today's session we will see top asynchronous FX questions which are generally asked in interview, and this is the part 1 of the series. So let's get started. So we have this first question on our screen is what is asynchronous Apex? So asynchronous Apex runs process in a separate thread without running and making the user wait. It helps to bypass Salesforce kernel limits. So you can see the same in the example code here that we have this logic to update industry field with this value technology, and we have this future method which is running asynchronously, and it is running in the background and updating the industry field of the specified accounts. So this is how we can separate the transaction and make our logic to run in a separate thread. So let's move to the next question. So we have why do we require asynchronous FX? So it solves kernel limit problem, and it allows callout from triggers, and it avoid mixed DML errors, and we can prevent CPU limit errors, and it runs process in a different thread. And you can see the same in the example code here that we are doing this callout from this trigger using our asynchronous FX logic. And this is true that it solves kernel limit problems because asynchronous Apex gives more kernel limit, and it is provided by the Salesforce. And we can also do the this call out from the trigger, which we have already seen in the example code here, and it avoids mixed DML errors. We will cover this in the next questions, and we can prevent CPU limit error. So this is true. We can bypass the CPU limit by just separating the logic in a different thread, and it runs the process in a different thread. This is something we have already discussed. So let's move to the next question. So we have types of asynchronous effects. So there are four type of asynchronous effects. First one is future method, then queuable apex, then scheduled apex, and then batch apex. So the first one is future method, and you can see the code of this future method here, and you can make any method future method by just adding this at the rate future annotation just before this method, and you can allow this callouts using this callout equal to true. Then we have this queuable apex here, and we have this class queuable example, and we are implementing this queuable interface here, and we are executing any logic inside our execute method, and we can enqueue this job by using this code system.enqueue job and instance of this apex class. Then we have this scheduled Apex example where we have this Apex class, and we are implementing this schedulable interface, and we are implementing the logic in this execute part, and we can schedule this Apex class using this boilerplate code here, that is system dot schedule and name of the job and the cron expression, which shows at what time or in which time duration our schedule Apex will run, and the instance of the schedulable Apex class. Then we have this batch Apex class. So we have this Apex class batch example, which is implementing database.batchable, and it has three methods in the interface. First one is start, where we create the data or fetch the data from our org. Then we have this execute, where we implement any logic. Then we have this finish method, where we can debug or do any job chaining and any other stuff. So we can use this database.execute batch and name of the batch class and the size of the batch to execute this batch. So let's move to the next question. So what are future methods? So future methods execute process asynchronously, at a later time to avoid delay in UI operation. So we have already covered this in the previous example that we have this future method, and this logic runs in a separate thread. So let's move to the next question. So why do we use future method? So there are so many use cases of this, like it improves Salesforce performance, and it handles large data sets, and it avoids kernel limits, and it scales efficiently. It prevents mixed DML error. And you can see the same in the example code here that we can do the callouts, and we can separate our logic in a separate thread, and we can also prevent mixed DML errors. So let's move to the next question. So what types of parameters are allowed in future method? So allowed parameters are primitive types, that is integer, string, boolean, or double, or list of primitives that covers list or array of string. So string or integer or boolean or etc. So these are not allowed, that is as objects, and custom fx objects are not allowed in future method. And you can see the same in the example code here that we are passing this list of string, that is list of imperatives, and we can't send this list of s object. So this is not allowed. Okay, so let's move to the next question. So can we call one future method from another? So the answer is no. Salesforce prevent future method chaining to avoid recursion. You can see the same in the example code here, that if we try to call a future method from a different future method, then this error will throw, that is future method cannot be called from a future or batch method. So let's move to the next question. So why can't S object be passed as a parameter? So the answer to this question is passing S object can lead to outdated data issue. So instead, pass record IDs and query inside the method. So this is true that the data can be outdated, as the future job will execute in any time whenever the system will be free, and before date that it might be possible that your data will be updated by some other user or by some other automations. So passing the ID is a better option, that whenever your future job will run, it will query the data, latest data, using these IDs. So let's move to the next question. Can we make callout from a future method? So answer is yes. We have already covered this thing, that we can use this callout equal to true after this future annotation to make callout. And you can see the example code here, that we are doing this callout to this URL, and we have this callout equal to true. So let's move to the next question. So can we add multiple future method in a single class? So the answer is yes. Multiple future method can exist in a single class, but still there are some limitations which we will cover in the next or in the future questions. So let's move to the next question. So what is a mixed DML error? So it occurs when performing DML on both setup and non-setup object in the same transaction. So you can see the same in the example code here, that we have this setup object, that is user, and we are inserting this user, and we are also inserting this account record, that is not that is a non-setup object. So it will throw this error, DML operation on setup object is not permitted after you have updated a non-setup object. Okay, so let's move to the next question. How to handle mixed DML error? So we can handle this mixed DML error by separating the transaction by using this at the rate future or queuable apex, or we can use this platform event. So you can see the same in the example code here, that we have this setup object user, and we are inserting this, and we are using this platform event to separate the transaction. Then we have this question: how does future method help in avoiding HTML error? So it separates setup and non-setup object operation into a different transaction that we can see in the example code here, that we have the setup object user, and we are also inserting this account record, but this is a future method which we are calling here. So this is separating the transaction, and we are avoiding this mixed DML error here. So let's move to the next question. So how to manage mixed DML error in test class? So you can use the system.runas or @future to separate transaction. So we generally use the system.runas, where you can see in the example code here that we have this test method, and we are inserting this account record, and after that we are fetching this user and using this user to insert this different user record. So this is how we manage DML mixed DML errors in test classes. So let's move to the next question. So can we monitor jobs in future method? So the answer is no. Salesforce does not provide job monitoring for future method for tracking. Use Quable Apex. So no job monitoring. You can't track future method execution through the UI or get job IDs. So limited visibility. You can only check debug logs to see if the future method ran. Use Quable Apex instead. If tracking or chaining is needed, Quable Apex is the better option. So let's move to the next question. So we have this: what are the limitations of future method? So it cannot take as object or list of as object as argument, and execution order is not guaranteed. So the way in which you have inserted the jobs will not be the same order of execution of the future method logics. So this is not guaranteed. Then Gardner limits are also there, that we can have 10 future calls per Apex transaction and maximum of 50 future calls per Apex invocation. And we also have this daily limit of future calls, that is 2.5 lakh, or number of licenses 200, whichever is greater. And job chaining in future method is not allowed. You cannot call one future method from another future method. And limited testing support is also there. So when testing future method, you need to wrap your test execution in test.start and test.stop. And you can see the same in the example code here, that we cannot take as object as an argument, and we know the reason behind this. Uh, and then we have this: execution order is not guaranteed. As you can see here, that we are executing this future method again and again, and it will we will not be sure thus about the order of execution. Then we have this Gardner limit example. So Gardner limit is we can execute 10 future calls per Apex transaction. After that, it will show error. Then we have this future job chaining, which we can't do. It will cause an error, and you will get a runtime error because future method cannot call other future method. Then at the very last, we have this testing future method. So we are limited to this test.start test.stop test to test our future method. So thanks for watching, guys. I hope you will like, share, and subscribe to my channel. And I will also upload the part 2 of this series. So see you next time. Bye.